Hi. So I was playing around with uh, this IC, which is uh, it's a 7-band graphic visualizer, and pretty much it's self-explanatory. So it has like 7 input filters at the following bands as shown, and the idea here is the system diagram or block diagram. Input comes in, it's got like 7 different filters, it's got a peak detector, and then using some logic from your controller, you can serialize the output and read the amplitude one after the other. And here I can see that if your input voltage is 300 millivolts peak to peak, you have about 4 volts typical, which is true, because if we look here on channel 2, I'm feeding a sinusoid of measure channel type channel 2 measure frequency. Yeah, so I'm feeding supposedly 63 hertz, and the peak to peak is 360 more or less. Obviously this is not very accurate, it's a super old scope, but anyway, we see here that yes, actually here have a capture between 2 different sequences. Like I'm triggering, I know that like for the first channel, like according to the logic of how this IC works, like you do the reset strobe, and then you read like the value of each of your bands, and I'm generating a tone of 63 hertz, so the reading is obviously as expected. And what I had this mistake because I was running it for a year, and I kept looking at the LEDs and how they're doing, and I noticed that like it's always like set on one color, but because like you're updating the LEDs like very fast, you cannot see the color changes, or maybe because I'm colorblind or something. But what I started to notice is that the LEDs, the colors were not changing, and then I noticed that like when I dropped the volume, I started seeing color changes. So it clicked that I'm saturating my input, or obviously I had another code mistake, but the initial mistake that I had is that I was saturating my input. And to show you how messed up it was, I'm gradually increasing the volume. As you can see, it's 200 millivolts per division. Let me just increase that so we can still see our signal. So this is as high as my function generator can go, and we can see here that the output is completely messed up, because instead of like seeing different 7 segments, we just see garbage, because we saturated all the inputs of those lovely filters, and to get it to work again, all we have to do is start reducing our inputs. See, right now we're at 2 volts per division. Let's make it 1 volt per division, 500 millivolts per division. So let's drop it some more. What's our peak to peak? Still 800. You see, still even at 800 millivolts peak to peak, still the second channel is reading some noise. Obviously, okay, this is actually something that this is another reason of why I was making this video. If you look here on the specs somewhere, actually this is sorry, I got sidetracked, but this is the logic of how to drive it. Basically, you do a reset and then you do strobes, and after each strobe, obviously there are certain timings that you need to follow in your code, but you read the value of each of your frequencies and it just repeats as you do the strobes. So yeah, so here's the other value. Like this IC has some kind of like noise floor, which is set to around somewhere here, yeah, 600 millivolts, okay? And it is pretty accurate, because if we move back here right now, look at my cursors. So I have one cursor which is set at 4 volts, okay? I'm exceeding it because obviously our input voltage peak to peak, because the peak to peak is still higher. So, and I have a second cursor 2 on 560 millivolts, cursor 1, so cursor 2, cursor 1. Each one of these cursors is set to a different value. One of them is set to the noise floor, one of them is set to the maximum value that we should get if we feed 300 millivolts peak to peak. So let's do so to see how that's going to measure. We still 500 millivolts peak to peak. I'm looking at this value, by the way. So where are we at? 360, 280. You see, if we're at 280, it's completely nullified. Like all the 6 other sequences, 1, 2, 3, 4, 5, 6, and this is the 7. So 1, 2, 3, 4, 5, 6, 7. We see here that they're completely as low as our noise floor gets, and obviously I think I went too far because I'm not hitting the maximum that I'm supposed to hit on my peak. Like my peak is at let me just increase this a little bit. Yep, okay, now we're good. So the increments on my function generator, like they jump from, if you look here on the peak to peak, 280, they jump to 360. So I don't really have much control over that, but if we are 360 still, channel 2 is a bit over the noise floor, or actually maybe it's at the noise floor, because if we remember, my cursor is actually at 560, but probably, yeah. So anyway, like we can ignore that, and you can actually clean that up in the code, because you can just like subtract this offset. You just need to calculate like this offset and just remove it. So here we see that it's dead on, so we are feeding our input signal is 63 hertz, which is one of the bands. If we look here, I'm feeding this first band, and if we look here, I'm following the specs. I'm feeding 300, more or less 300 millivolts peak to peak, and I can see my output clearly to be as expected, around if we use the cursors, yeah, 4 volts. So, and that's what they say here. If you feed, this is the noise floor they mention, and yeah, so if your input voltage is, this is actually like was a test condition, but apparently it works all over. So like it works at the low band, so 0.3, and our output swing should be to 4 volts. And let's try So let's try what? Let's try 1K is, I don't want to do 1K. Let's try 625. So let's go to my function. This is an online function generator that I'm using. So what was the value? We said 625. 6250. Okay. Lovely. And this is supposed to be which band? This is supposed to be 1, 2, 3, 4, 5, 6. Okay, so obviously it's in the same location because the scope is triggering where I'm setting the trigger, but this would be the 6th channel, this would be the 7th channel, this would be 0, 1, 2, and so on. Okay, and here we see it's still good. Now let's see if I increase the input, what's gonna happen. So we see, obviously, actually let me do this. Yep, I had to do that. Obviously we cannot see both of them at the same time. Like, my scope is very horrible, so I cannot like measure frequency accurately and see the first channel at the same time. That's why like he's approximating here, but we can clearly see that when I like zoom in, I can see the frequency that I'm setting. This is not a frequency counter, so it cannot like do that. But anyway, if you go to where we can see like our sequences, as before we were looking at 2 separate sequences, we see that it's still doing great with a peak to peak of 360. Now I'm curious what's gonna happen if I increase and we start exceeding our noise floor on the other channels. So if we drop it back to 80, yep, 360. Yeah, so more or less the same. Like I'm actually glad I caught this mistake. If anyone wants to take a look at the circuit or see my code, I would be happy to share that with you guys. For the time being, stay tuned for next updates to follow.